Let's examine what it means to say that everything in MATLAB is a matrix. One of the key differences between MATLAB and other programming languages like Java or C is that MATLAB is built from the ground up around working with matrices and large data sets. This focus can be confusing and counterintuitive, but it also makes MATLAB one of the most efficient programs to do statistical analysis with once you figure it out. To start with, I'll open up a new script by clicking the New Script button. This opens a pop-up window where we can write all of our code. I'm going to start by writing 3 different types of variable definitions. First, a equals 3. This means that a is interpreted as a scalar with a value of 3. Next, I'll put b equals bracket 3, 4, 5, semicolon 1, 2, 3. This tells MATLAB that b is a matrix. Commas or spaces separate different values on the same row, and semicolons or new lines separate different rows. Finally, c equals 1:3 causes c to be interpreted as a vector. MATLAB automatically expands 1:3 to be 1, 2, 3. If I save and then run this file, you can see that this is exactly what happens. Now, this might seem confusing at first, because there's no way to know whether a given variable was a scalar, a matrix, or a vector, but in reality it doesn't matter. As far as MATLAB is concerned, a scalar is just a 1-by-1 matrix, and a vector is just 1 by n or n by 1. This makes things very simple because the exact same types of operations can be used on each of the different variables. To see how this works, I'll add 2 new lines. First, a times b. Since a is a 1-by-1 matrix, it is interpreted as a scalar and multiplied by every value in the matrix b. Next, I'll put in c times b transpose. Now, you can't multiply a vector by a matrix, so MATLAB automatically treats c like it's a 1-by-3 matrix instead. The apostrophe after b tells MATLAB to transpose matrix b. I have to do this in order to make the inner dimensions of b and c match. Now, since we're dealing with matrices, MATLAB treats the asterisk as matrix multiplication rather than scalar multiplication. Anytime there is no ambiguity about what kind of operation you want, MATLAB interprets your functions in the most appropriate way, which saves a lot of time that you might spend defining and choosing a bunch of different functions to handle matrix multiplication, scalar multiplication, dot products, and so on.